Hi everyone, sorry for the lack of activity in my blog. Unfortunately, I've been very busy with life and work and moving house and fixing the house and all kind of stuff, so I haven't had time to do a video. But I bought this stuff from an auction, so I thought it'd be a good video and good teardown. What this is Nokia data and voice link. You see these stuck in the towers, the cell phone towers, and you got this stuck to a pole, and you got wire coming into the actual unit that does the processing and all the other signal conditioning and the rest of the stuff. Basically what this is just the sender and the receiver. Obviously when you want to have something that is not easily accessible, you want to put as little as possible inside this and have the rest down at the station where you can, if something goes wrong, you can fix and modify and replace. These have a mean time, mean failure time up to about 30 years. So on its own rank, on its own thing, it is quite nicely built and designed. So you can see here you got massive heatsink at the back here, obviously to heatsink the receiver and the transmitter, because it's going to probably use a lot of power. And what you got over here is you got warning sign, and if I take the cap out, the warning sign says do not look inside this. We've got a picture of an eye and then 25 centimeters, so do not look into this directly, closer than 25 centimeters. So if you want to look inside, you got to be further away than 25 centimeters. Otherwise I think the microwave in here might do some damage to your eyes or something like that. But anyway, what we got here, we got you can read it. We got Nokia over there, and then we got Flexi Hopper 13, frequency range 13 gigahertz, class 2. And you got two signal coming in, going out or coming in or whatever. We got one for it says FB plus, and one we got AGC plus. So anyway, taking this apart was a bit of a dog, because these screws, obviously these been inside the elements, been subjected to elements outside, so cold, hot, all kind of rain and all kind of crap. So these screws are really hard to open up. I mean, I tried really hard. I opened 3 of them, and always when you're trying to open something, the last screw is the one that gets you. Anyway, I had to use hammer and a chisel and all kind of stuff to get what's inside. And what's inside, it is a lot of RF goodness. Let's see. So this is what's inside. So you got one board, you got another board, and you got another board in there, and then you got another section over here. So clearly this is where the amplifier and the signal comes out into this and spits out of there. So let's get this into different parts and see what we get. Firstly, let's see this aluminium, whatever it is. As Mike said from Electric Stuff, at this kind of frequencies they don't use wire anymore, they use plumbing, and you can clearly see why that is. There we go. So we got here, we got 2 form of cavities. I don't know, one for signal going in, one signal coming out, TX, RX, or whatever it is, I wouldn't know. And what we got here, we got all kind of screws here, locked with the screw glue lock or whatever it is. These form kind of filters with inside this cavity, and then you got signal coming out of here. It's not that heavy. And what we got over here, we got FOHB 13.059 gigahertz, and then we got FD 0.266 gigahertz. I have no idea what that means. If anyone knows what that means, leave it in the comment. But yeah, that's a nice piece of machine aluminium for sending a signal, spitting a signal out. But that's one thing. And then what we got here is this section. Now what I've done, I've taken the screws out because there's a lot of screwing in this to just make our life easier. So we got this bit, and you can see individual section, and you can see the individual section in there, and then you got all the gold plating and stitching which meets with this to isolate every single section of this board to make sure that the signals don't interfere with each other. And then what we got over here, we got this bit. Now as I said, I've unscrewed everything, so I'm just gonna take it apart. No doubt by me just touching this and taking it apart, I have obviously damaged this unit or changed its characteristics. What does this say? Filtronic broadband. So maybe this is used for data and not voice. Who knows? Anyway, let's take this further apart. Everything is nicely sandwiched together. Okay, so we got these sections. Now let's start from the very beginning, which is this. As you notice, there is no power connection to these. Oh, you had the ACG and you had the FB. So where the power coming from? At these frequencies, the power actually comes really into the signal itself. So you got this. I don't know which one of these is the input, but let's just say either this or that is the input. Then you got some form of filtering over here. Go there, again filtering. Then you got, with this filtering, what you get the signal and the DC. So they separate the signal and the DC, and the DC is fed to the DC-DC converters and voltage regulators, and there will be your voltages that you need to run this unit. So at one point I'll show you what voltages this runs at. I actually did connect it to my power supply, and I did feel a kind of warmth coming out of this, which I don't think was healthy for me to have it running in my room. So I quickly turned it off. I mean, I held my hand above it, and I did feel something against my hand, so I quickly switched it off because I didn't want the microwave to start jumping around in my room. But anyway, so we got you can follow the signal path over here. We get into here, then we got into DC-DC converter, and we got these transformers. Now, the weird thing about these transformers is usually when you get transformers for DC-DC converters, if I can find any, let's see. Let's get one transformer for a DC-DC converter. Anyway, let's just get an inductor for a DC-DC converter or whatever. AC, inductor or transformers, you see wires going around. But on here, you don't have any wires. What you got is lots of layers of kind of a flex cable, kind of like this. And they're all stitched and glued together. Now, I don't know if it's clear enough for you to see over there. What you got is they got a PCB track running around like a coil, like so, and they're all stitched together to form the coil inside this inductor, which is very clever. This way, I believe, not only makes it cheaper to manufacture this, but makes it easier and simpler for them to manufacture this. But anyway, you got these Payton or whatever it is, Planetics coils or whatever they are. But anyway, these what forms the DC-DC converters, and you got a lot of MOSFETs and diodes and a whole lot of other capacitors and stuff to get your voltages. And what you get the signal and your voltages going out of into this flex cable here. And one thing about this is I don't know if it's clear on the video here, but the flex cable is actually coming from the middle of the PCB. So it's kind of almost like they had this PCB and they had the two sides sandwiched together and this in the middle, which is kind of neat. If the camera focuses, there we go. You can see that this is coming from the middle of the PCB. So yeah, that is that. And yep, if it's clear or not, probably not. Oh, we got the voltage 27. So you got 27 volt there. You got 5 volt. We got 3 volt, and we got 6 volt. And one of these 5 volt on the other PCB that you see, you got 5, and you got -5. So you got all the 3 or 4 different voltages. You got 5, -5, 3, 6, and 27 volts coming out of here from just one signal input here. You get all voltages coming out of there, which is a clever idea. Anyway, that was that, and up to the next board. So what we got here, we got again what might be DC-DC converter or filtering again. Then we got the couple of analog devices DACs. We got TX DAC. I believe this might be 10 megabit DACs. Down here, then we got a lot of filtering, which are for these ICs over here. So we've got a lot of caps and a lot of resistors and clock for the Motorola and the other ICs. So we got some op amps and some miscellaneous stuff, and more filtering and more op amps on this side. And the other side, what we got here, we got some NEC processors. And we got here, then we got our voltage controlled oscillator, which is running at 37, if it's clear or not, better get a better camera, 37.72 1020 megahertz. And these are voltage controlled oscillators, so they are trimming the oscillator with I believe what might be voltage reference or whatever it is. And we got another one over there on this side, and it's got its own oscillator, and we got some op amps, and we got some comparators, some linear technology comparators over here. We've got a lot of filtering, inductors, capacitor filtering. On this side, I believe this might be the signal going out. That's why we might have all this filtering over there. And we got some, I believe it might be some LEDs. Yeah, we got some LEDs for the status on this board, which comes out of that. There we go. Which comes out of the here. So we got is it IF lock? Or T, not, yep, IF lock. This, and we got MWU lock, which comes out of here. And then we got this, which was, I think, that over there. There we go. And we got one side which is all ground, and the other side it says RX tune and TX tune. So yeah, it might be like a little debugging panel here that connects, and you can debug or get information out. But anyway, that was this board. And one thing you see when you get to this kind of PCBs is to tell you how many layers this PCB has. If this camera wants to zoom, doesn't like to zoom, this stupid camera of mine. Anyway, this is 12 layer PCB. If we go over here, we got the, there we go. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the middle one, 11, and then we got the 12. We got 10 over here, and then we got 12 at the end of there. When you just hold this against the light, you can see 12 written there. But yeah, this is a 12 layer board. You can go over there. Then we got this, and now it's starting to go into more interesting bits. So we're going into the actual signal now. So every layer that we digged in, we had the power supply, then we had the processing control. Now we're going into the RF section, and then the last one will be the actual RF amplifier and the rest of the voodoo magic, that stuff you see. So what we got here, we got the signal here, and you can see at the back it's all gold plated. A lot of stitching going on, wire stitching going around here to minimize inductance and to control inductor and inductance, and to control the path of the signal that they want, you know, the controlling over wherever you want it to go. So we got the signal coming in from over here maybe, then we got some conditioning over here, then we can actually follow the signal path over there. We got some filtering, some might be some amplification, and another thing is the signal is going to this side as well. It might be for filtering or conditioning or for sampling, because we do have LED here, and we got all kind of processing over here. So it might be that is measuring the signal and making sure everything is alright and giving you a status LED over there. Anyway, the rest, the signal is going through here. Again, we got amplification, we got some filtering over here, then we're going into an KNL microwave included, so it's a KNL filter over here. Then we got into there, and the signal disappears into this little via. So now where the signal is gone, it's clearly, you can easily see that you got this kind of a path that is traveling all the way to here. Now, how would you know the signal is traveling there? Because you got via stitching on both sides. So what they're doing is trying to eliminate any signal from coming from either side into this middle path over there, and same as the other side. So you got the signal coming in here, and then you got it traveling all the way up to here. Now again, the signal comes into this little wire and then comes in here. We got a capacitor here with a footprint for maybe more capacitor or resistors, and then we got signal going into here, and then signal going into this connection, which connects into the final stage of the signal, what might be the amplifier or whatever the other thing is. We're going to open it up and take a look. And then we got again at this end, we got the signal coming here and getting sampled into this bit and going into some other form of circuitry. And what we hear, oh look, we've got a little nice, what is it? A little mouse? Yeah, look, it's a mouse within a mouse. How cool is that? We got clear. Come on, there we go. We got a big mouse and we got a little tiny mouse inside that. How cool is that? That is nice. But yeah, we got some form of other conditioning over here as well. So we got some voltage controlled oscillator over here. We saw in circuitry, and we had another one over there. And let's see what they read. This is 17.500, so 17.5 megahertz, and this is exactly the same, 17.5 megahertz. Made in Japan, and I don't know where this is made. It's probably Japan as well. But yeah, so this was another bit of signaling, and now we're going to go to the final bit. Let's see what's inside this. It's got a lot of screws as well. As you're digging inside, the screws are getting smaller and smaller. So by the end of you opening this, you have a lot of screws to use in your projects. If you're not ever going to use this kind of stuff again. Oh man, definitely need a electric screwdriver to deal with this kind of stuff. Alright, there we go. Again, as you can see here, we've got all kind of compartments here for keeping the signal from interference and jumping from one section to another section, because at these frequencies it's very easy to get leakage and stuff. And where we got here, so now we're getting into the magicy bits. If my camera focuses, it doesn't like to focus, but yeah, there we go. So what we got, no idea where the signal is coming from, which direction, but I know where the signal is going out, which is here. And you can see here, these are where the signals are disappearing into that thing that we had here, if I can get it. So we got here, and we got this, and this. You can see here, this connects into here like so. Nope, I believe it was down there. Yeah, it is down there. Oh no, it's the other side. There we go. So this connects like here. So what you can see, those two rectangular patches with the little wires coming out of it, gold plate coming out of it, that's where the signal is being generated and passing through these cavities and coming out of there, mixing together and coming out of there. So I have no idea what these are. Probably amplifiers, because they got no marking. They got some weird marking on them, but you got the signal and power coming from these PCB connects, and you got all kind of weird stuff going around inside here. So I wouldn't claim to understand what the hell is going on there, but what we have here is a 13 gigahertz solder DAM, and then you got that, and you got a date code 2001. So yeah, you can see, no doubt these amplifiers are very expensive, and we got some weird alien shaped filtering going around here, as you can see. At these frequencies, these little shape, these are capacitors for you. What we got here, we got the tiny little, I don't know if it's clear, there's tiny little, I don't know what they are, might be resistors, capacitors, but they're too shiny. They look like silicon. They're too shiny to be capacitor or resistors. So I believe, yeah, you can see it shines. You can see it shines. So it's probably some form of silicon something. I don't know what they are. Might be diodes or something. But yeah, look at all that stitching everywhere. Now this is not a PCB. This is some form of I don't know what it is. Some form of board. But this board is been sandwiched into this metal bit, so it's not a PCB that you can take off. So because you got these power amplifiers here, then these are all coupled into this big massive aluminium thing for cooling. So there's no way that I can take this off without damaging the whole thing, and it's very thin anyway, the layer. So by me pulling it off, everything's gonna just break. So there's no point of digging in deeper into this. But yeah, this is inside a 13 gigahertz Nokia data and voice link. And this is the back. The back does open up and comes up, but not these. It's only this little bit. It's only that little bit that comes out. The rest won't come out. So this is as far as I will go with this. Because I do want to put this back together. This is this little one that I have here, which I've opened up. This is my own, and I have the rest of them on my eBay shop for sale. If anyone's interested, I will leave my eBay shop address, web address on the comments. And if you're interested, go take a visit. I do have a lot of other RF stuff. If you're into RF or other things, to take a look at. But anyway, yes, I hope you enjoyed this. I might do more videos later on, but at the moment, as I said, I'm very busy with moving. At the moment, my room is a mess anyway. I haven't had time to sort my room out, but yeah, I haven't really had time to make videos and stuff because of work commitment and life commitments that I have. But hopefully in the near future I might do more videos. But anyway, if you like the video, please give a thumbs up, and until the next video, thanks for watching and goodbye.